Earth, Moon, and Sun. This is Lesson 2, Earth in Space. Before we get too carried away with this section, misconception alert. The misconception that many people have is that the seasons change because Earth's distance from the Sun changes. So people think that during the winter months, we're farther away from the Sun than what we are during the summer months. This is actually the opposite. We are actually closer to the Sun during our winter months than we are during our summer months. The seasons do not depend upon how close we are to the Sun. Rather, they depend on the tilt of our planet. So the seasons are a result of Earth's tilted axis. The evidence that we have for this is the following. Earth's distance from the Sun does change, but that's not why Earth has seasons. If that were the cause, people in the northern and southern hemispheres would have the same seasons at the same time. Instead, seasons in the northern and southern hemisphere are reversed. As Earth moves around the Sun, sometimes the northern hemisphere is tilted towards the Sun. At other times, the southern hemisphere is tilted toward the Sun. When we have a tilt toward the Sun in the northern hemisphere, we get summer. When we are tilted away from the Sun, the northern hemisphere experiences winter. So our seasons are not dependent upon the distance from the Sun. They are dependent upon the tilt of the Earth. So how does the Earth move? Until a few hundred years ago, most people thought that Earth stood still and the Sun, Moon, and stars moved around it. But today, scientists know that Earth itself moves, and the objects seem to move across the sky because of the Earth's motion. Earth moves in space in two major ways. They are rotation and revolution. Rotation. The imaginary line that passes through Earth's center and the north and south poles is Earth's axis. The spinning of Earth on its axis is called rotation. This is what causes us to have day and night. As Earth rotates eastward, the Sun appears to move west across the sky. As Earth continues to turn to the east, the Sun appears to set in the west. Sunlight can't reach the side of the Earth facing away from the Sun, so it is night there. It takes Earth about 24 hours to rotate once. As you know, each 24-hour cycle of day and night is called a day. Revolution. In addition to rotating, Earth travels around the Sun. Revolution is the movement of one object around another. One revolution of Earth around the Sun is called a year. Earth's path, or orbit, is slightly elongated. This is called an ellipse. Earth's orbit brings the path of our planet closest to the Sun in January. Our Earth is on a tilt of 23.5 degrees. The tilt causes our seasons. In this case, based on this picture, we see that the tilt causes the southern hemisphere to have more direct sunlight. This would be summer months for the southern hemisphere. as that changes throughout the year, we would end up in summer for the northern hemisphere. Calendars. People of many cultures have divided time based on the motion of Earth and the Moon. They have used the motions to establish calendars. A calendar is a system of organizing time. The most common calendar today is divided into years, months, and days. 1 year equals the time it takes Earth to complete one orbit. 1 day equals the time it takes Earth to turn once on its axis. People also divide the year into months based on the moon's cycle. The time from one full moon to another is about 29 days, though modern months do not match the moon's cycle exactly. The Egyptian calendar. The ancient Egyptians created one of the first calendars based on star motions. They calculated that the year was about 365 days long. They divided the year into 12 months of 30 days each, with an extra 5 days at the end. The Mayan calendar. Many of us are familiar with the myths associated with the Mayan calendar. The Roman calendar. The Romans borrowed the Egyptian calendar, but Earth's orbit actually takes about 365.25 days. The Romans adjusted the Egyptian calendar by adding 1 day every 4 years. You know this 4th year as a leap year, when February is given 29 days instead of its usual 28. Using leap years helps to ensure that annual events such as the beginning of summer occur on the same date each year. And the Gregorian calendar. The Roman calendar was off by a little more than 11 minutes a year. Over the centuries, these minutes added up. By the 1500s, the beginning of spring was about 10 days too early. To straighten things out, Pope Gregory dropped 10 days from the year 1582. He also made some other minor changes to the Roman system to form the calendar that we currently use today. So what causes the seasons? Many places that are far from Earth's equator and its poles have 4 distinct seasons: winter, spring, summer, and autumn. But there are differences in temperature from place to place. For instance, it is generally warmer near the equator than near the poles. So why is this? One reason is how sunlight hits the Earth. This picture shows how sunlight strikes Earth's surface. Notice that near the equator, sunlight hits Earth's surface from almost overhead. Near the poles, sunlight arrives at a steep angle. As a result, it is spread out over a greater area. That's why it's warmer near the equator than near the poles. Looking at the picture, this table shows the hours of daylight that are received based on different times of the year. On January 1st, Finland only gets 5.98 hours of daylight, and they are at 60 degrees north. Philadelphia, USA, actually ends up with about 9.38 hours of daylight during January 1st. And notice these changes as we go through the year. Another reason for our seasons is the tilt of our axis. We set at a 23.5 degree tilt. That tilt does not change. During our summer solstice, the northern hemisphere is directly towards the sun. And as the year continues, we get to the winter solstice, where the northern hemisphere is tilted away from the sun. These changes as our planet orbits the sun leads to our seasons. So if Earth's axis were straight up and down relative to its orbit, temperatures in an area would remain fairly constant year-round. There would not be any seasons. Earth has seasons because its axis is tilted as it revolves around the sun. We are tilted at a 23.5 degree angle. The North Pole always points in the same direction. And remember that that North Pole points towards the North Star. As Earth revolves around the sun, the north end of its axis is tilted away from the sun for part of the year, and toward the sun for the other part of the year. Summer and winter are caused by Earth's tilt as it revolves around the sun. So direct solar radiation towards the northern hemisphere when it's tilted towards the sun. Not so direct radiation from the sun as we are tilted away. So this would be our winter. This would be the northern hemisphere's summer. Solstices. The sun appears farthest north of the equator once each year and farthest south once each year. Each of these days is known as a solstice. The day when the sun appears farthest north is the summer solstice in the northern hemisphere, and the winter solstice in the southern hemisphere. This solstice occurs around June 21st each year. It is the longest day of the year in the northern hemisphere and the shortest day in the southern hemisphere. The sun rises to the northeast and sets to the northwest. Similarly, around December 21st, the sun appears farthest south. This is the winter solstice in the northern hemisphere and the summer solstice in the southern hemisphere. The sun rises to the southeast and sets to the southwest. Equinoxes. Halfway between the solstices, neither hemisphere is tilted towards the sun. The noon sun is directly overhead at the equator, and it rises due east and sets due west. Each of these days is known as an equinox, which means equal night. During the equinox, day and night are each about 12 hours long, everywhere. The vernal spring equinox occurs around March 21st. And marks the beginning of spring in the northern hemisphere. The fall, or autumn equinox, occurs around September 22nd, and it marks the beginning of fall in the northern hemisphere. So our sunlight distribution during the equinox, the sun is directly over the equator, so both sides of the equator get relatively the same amount of solar radiation during the equinoxes. This picture shows our different solstices and equinox. Notice in the northern hemisphere for the June solstice, the sun is highest in the sky. And by the time we get to the December solstice, the sun is lowest in the sky. These are opposites for the southern hemisphere. So when we're having summer in the northern hemisphere, the southern hemisphere is having winter, and vice versa.